All right, so this is your assessment of basically the first half of Unit 3. Okay, so the stuff that's covered in this assignment is T equals 1 over F and F equals 1 over T. That stuff can be covered in here. Okay, this can be covered in here. V equals 2 pi R over T. So understanding, okay, how to calculate velocity given just the period and the radius, or the frequency and the radius, because this can also be written like that. Okay. Other things that are covered in here: centripetal acceleration. So you may have to use AC equals V squared over R. And then all the stuff on centripetal force. All right, so you could have some questions that are very simple to do with centripetal force, where it's just this formula. Okay, but you're also going to have some banked curves, some unbanked curves. Okay, maybe artificial gravity, as well as vertical circular motion. Okay, so remember things like in an unbanked curve, friction provides the centripetal force. Okay, in a banked curve, okay, theta equals, the tan of theta, not theta, the tan of theta equals V squared over R times G. And obviously our vertical circle stuff, okay, where FC equals forces in minus forces out, right? All of that stuff is on here, okay? Not the Kepler stuff we talked about yesterday, right? That stuff is not on here. All right, so my biggest tip for you is this: don't overthink a question if it seems really easy, because it probably is, like question number 1. Okay, where you're simply being asked for how much time it takes these blades in a blender to make 1 revolution. Okay? It's not like a multi-step question. It's only out of 3 marks. Okay, givens, formula, plug in the numbers, show me your answer. Okay, like it's not rocket science. It's part of rocket science, but it's not rocket science by itself. Okay. For question number 2, okay, you got a horse going around a circular track. Okay, they're giving you the time it takes to go around. They're giving you the speed, asking for the radius. Again, it's only out of 3 marks. It's not an overly difficult question. Okay, number 3, okay, magnetic tape is being spooled from a supply reel to a take-up reel. You guys, this is like a generation gap question because you've probably never seen one of these things. But we used to have these things called tapes, and they were about this big, and you could put them in a slot in your car, and music would play from them. They were really cool. Very portable. Awesome. Okay. They suck compared to what we have now. Okay, but that's what we had, and basically it was just magnetic tape, and there was one reel on one side that would spin, and it would pull the tape off the other reel. Okay, so you have one reel that's got a bunch of tape on it, one reel that's got none on it. That one spins and pulls the tape off of the other one. So the tape is just being wound onto a reel. Okay, and it's doing that with a speed of 0.191 meters per second. They're giving you the radius. They're looking for the magnitude, okay, and direction of the centripetal acceleration of the tape. Okay, so looking for the acceleration, but also direction. So if it specifically asks for it, you should write it down. We said that most of the time, if something is centripetal, we don't bother writing the direction because it's kind of a given. But if it does ask for it specifically, make sure you include it. All right, number 4, okay, race car going around a circular track, radius is 2.6, goes around the track in 360 seconds. You're looking for centripetal acceleration. There's kind of a long way and a short way to do that one, but they're both correct. Okay, number 5, okay, again, you're given a centripetal force there. It's not an overly difficult question, don't overthink it. Okay. Child is twirling a ball in a horizontal circle, okay, so kind of like what I was doing with the tape that day in class, okay, so that kind of question. But it does ask you to explain something, okay. If the speed is doubled, does the centripetal force double, all right? If not, by what factor does it increase and why? You may or may not have to do the math to prove that. It's up to you, okay, because you may know what it is already, okay, and you can just explain it. For number 7, they're looking for the angle of a banked curve. Okay. For number 8, you're looking at another banked curve. Number 9 is talking about apparent weightlessness when going over a vertical circle. Okay. Number 10, also a vertical circle. Okay. Number 11, roller coaster, vertical circle. Okay. Number 12, okay, is an arc, but it's the bottom of the arc, which is like the bottom of a vertical circle. Okay. And then number 13 is an unbanked curve. Right. So we've done tons of questions like all of these before. There's nothing on here that should surprise you. Okay, not like on the Newton assignment where I put a few on there that really made you think. You've done at least a half a dozen of every one of these questions already. Okay, so you got the rest of class to work on this. If you got questions, let me know. Okay, and I will help you a little bit. But because this is an assignment, I need to know what you know, not what I know, which ain't much. Okay.